All right, for today, lesson 6, interior angles of polygons. We are going to focus in on all types of polygons. Some might seem familiar to you, some may not, but always keep in mind that you are going to be focused on how many sides the polygon has and what the question is asking you to find. So we're going to kind of focus on this equation first. So we're going to focus on s equals n minus 2 times 180. Where S stands for the sum of the interior angles, and then N stands for the number of sides in whatever polygon you're working with. So looking at 1, 2, and 3, we're just going to focus on using that equation and finding the sum total of those 3 polygons. So in number 1, we know it has 4 sides. So when we find its total sum, we're going to take 4 minus 2, and we're going to multiply that by 180. So we know that 4 minus 2 is 2, and 2 times 180 gives us a sum of 360 degrees for any figure that has 4 sides. It doesn't even matter if it looks like that trapezoid. Any figure with 4 sides is going to have a sum of 360 degrees. Moving over to the triangle, we know triangles have 3 sides. So when I take the total sum, 3 minus 2 times 180, you get 1 times 180. So the total sum of a triangle, which I'm sure most of you knew anyway, was 180 degrees. What I want to focus on here is not every shape is going to be a familiar shape, but the rule doesn't change. Like if it's a 4-sided shape, it's 360. If you can memorize that, that's awesome because it's going to save you a step in some of your work. 3-sided shapes, no matter what they look like, 180 degrees. So we're going to focus in on this hexagon. We know that hexagons have 6 sides. So the total sum is 6 minus 2 times 180 degrees. For that, we get 4 times 180. So a total sum of 720 degrees for any 6-sided polygon. So that's kind of the basics for this lesson. Now moving on, we're going to see some where we're going to need to find the total measures that it would equal in order to find the missing angle measure. So zooming in on number 4, write and solve an equation to find the missing measure. So this is a 4-sided shape. So just to kind of reiterate from what I was just talking about, above, we found that a 4-sided shape has 360 degrees. If you did not know that, you would need to do the work that we did here in order to apply it to a shape like this with 4 different sides. Because we know that shape looks kind of like a kite or an airplane, paper airplane, we know that that shape also has 360 degrees. So we can find that missing angle pretty easily by saying if we add the 3 sides we know plus the variable, we can set it equal to 360 degrees. This makes this a pretty simple algebra problem with 42 plus 42 plus 78, which gives us 162 plus x equals 360. And when I subtract 162 from both sides, we get 360 minus 162. So that degree of x is 198. Now that might look a little odd, a degree over 180 degrees. It's obviously this would make a straight line here. And we can see that that goes beyond that straight line, which is why that is beyond a 180 degree angle. All right, moving on to number 5. Number 5 is a 1, 2, 3, 4, 5, 6-sided shape. Again, focused on what we did above, we already know that a 6-sided shape, this hexagon, has 720 degrees for its interior angles, so we can use that and apply it to number 5. So once again, we're going to take all of the angles we do know, 75, 102, 136, 2x, yes, that one counts, plus x, plus 92 equals 720. We're going to combine those like terms. So we obviously have a whole bunch of whole number like terms. So 75 plus 102 plus 136 plus 92 gives us 405 degrees, plus 3x, because I have two coefficient x's, equals 720, takes us into solving a two-step equation versus a one-step equation. So we take away that 405 from both sides. So we get 3x equals 315. We divide by 3, I almost said 5. And we get 105 for x. Now it does ask us to find the missing angles. So we do know that one of those missing angles is x, so we can say 105 degrees. But then we have another one where we actually have to multiply that 105 by 2, another angle over 180. So we end up having several answers to this problem with x and the two angle measures. Moving down a little further, find the measure of each interior angle of a regular polygon. So these problems are more like your problem-solving problems. So we're going to start with number 6. It has 5 sides. So you need to know kind of what to do. So we need to find, first of all, we need to find, what all these equal total. So we're going to use that sum equals the sides minus 2 times 180, which gives us 3 times 180. Sum of 540, but we want to know what each interior angle is. So if this is a 5-sided shape at 540 degrees total, we're going to divide it by 5 to know that each angle measure is 108. So each of these angles is 108 degrees. What is the measure of each angle in a regular 16agon? So we're not going to draw a 16agon, but we're going to do kind of the same process we did in number 6. We're going to use the sum total to find the interior angle measure total. So that gives us 14 times 180. And 14 times 180 is a sum of 2,520. But we know this shape has 16 sides, so we're going to divide that total by 16. And it's okay that we have a decimal. That means each angle for that 16agon is going to be 157.5 degrees. Yes, you can have angles with decimal measures. Moving down to number 8 and 9. The sum of an interior angle measure in a regular polygon is 1800. So it's telling you this shape, no matter how many sides or how many angles it has, it's 1800 degrees inside. How many sides does the polygon have? Okay, so this time we're going to use that same equation, S equals n minus 2 times 180. We know the sum of the interior angle measures. It's 1800, so we're going to work ourselves backward by putting that in for the sum and then finding out n by doing some backwards work. So let's divide by 180 first. So we're left down to our parentheses, and we can cancel those 180s out. So I have 1800 divided by 180. That gives me 10 equals n minus 2. And I obviously am going to work, I'm going to minimize this a little bit, by adding 2 to both sides. And that tells us the number of sides is 12. Let's do one more like that, where we have a sum of interior angle measures that equals 2160. So we're going to put that in for our sum. We have n minus 2 equals 180, working backward through inverse operations. We're going to divide by that 180 on both sides. So I have 2160 divided by 180 degrees. That gives us 12. And when I add 2 to both sides, I get n is equal to 14 sides. So again, I'm still applying that S equals sides minus 2 times 180, just in a backward route. Number 10, the sum of the interior angle measures is 2520. What is the measure of one of the interior angles? So now we're asking to find the measure of one. So we know them all. We do not know how many sides it has, so we have to figure out the n first. So we're going to take what we did like in number 8 and 9. Let's concentrate on figuring out how many sides does this shape have first. So working backward again, we have 2520 divided by 180. That gives us 14. And when I add 2 to both sides, I figure out that this shape has 16 sides. So the question though is asking, what is the interior angle a measure of 1? So in this case, I have to go back to a step 2, take the total interior angles divided by the sides. And when I do that, 2520 divided by the sides 16, I get 157.5. And this should sound familiar because we just did one back in number 7. Just like that in a different route. Last problem, number 11. In number 11, the interior angles of the regular polygon each measure 135 degrees. How many sides does the polygon have? So the only thing we can really work from is this right here. So we know that we have 135 for each angle measure by itself. How many sides does the polygon have? We don't know the number of sides and we don't know the total. So this is an interesting problem because I am drawing a blank and feel like we missed something on number 11. So you know what, I'm going to come back to that and maybe I'll post about it separately from this, but I'm going to think on this one because I really think we are missing, or maybe we can talk about this in our Zoom call today. So the interior angle measures of a polygon, a regular polygon, each measure 135 degrees. How many sides does the polygon have? I have to think on that one. So let me get back to you on that one. I feel like something is missing in that problem. So go ahead and do the first 10. If you can figure out number 11 and I'm just not thinking clearly, because let me tell you, it's been a rough go at e-learning for me and e-learning for my daughter. You go ahead and let me know if you can figure it out. I'm going to think about it separately and I'll get back on Canvas